Everybody for coming. It's a great pleasure to introduce Rafael Marti to Microsoft. Rafael is a security visualization specialist who happened to be in town for SecWest, which is going on in Seattle this week, where he gave the keynote yesterday, Monday. Okay. Now Rafael has been working in the visualization field for many years now. He literally wrote the book on security visualization, which I have up here and pass around here in a second. That was back in 2009. Eight. And since then, he's been working at a variety of startups in the Bay Area on data analytics and visual analytics, now with the company Pixel Cloud. Today, he's going to talk about security visualization, in particular looking at how to visualize or how to deal with large data quantities, a very relevant problem to WSP. Rafi, I'll let you take it from here.
Thanks for having me here today. I have never been to the Microsoft campus before. It's kind of exciting to be finally out here. Is it okay if I don't use the microphone? I'll try to speak up. Can you hear me with that? Good. All right, so I want to start my talk with this quote here from Dos Schweiz's 3 Barriers. You make your way through the darkness of abandoned grasses, searching for meaning. As you do, where is the meaning? So this is a quote or a story or a riddle, or as the Zen monks call this, is a koan. And it's really about sort of the searching for the meaning of life. And if you're practicing any kind of sort of meditation or maybe even Zen, then at some point you realize that you don't really have to go out into the mountains of the Himalayas and like sit with the monks for 2 months and don't speak to find the meaning of life somewhere out there. But it's always right there. It's right in front of you. The meaning of life is here. And I'm using this quote because the parallels are very interesting between our data analytics and this, where the meaning is right in the data. We just have to know how to look at it. And we sometimes don't. And that's sort of fitting to the talk, I guess. So what I'm going to do is I first want to show you or motivate you a little more that I think security visualization is the most exciting field out there. I'm going to talk about why security visualization is hard. And I think if you look at what tools are out there and what people have been doing, I'm a little underwhelmed every now and then with what I've seen. And there are some reasons for that, I think. But I'll also show that it's really not that hard. And one of the things that I realized a little while ago, again, is that we forget to sort of put the user back in the center of things. And I always hate it when people talk about that kind of stuff, of like product management frameworks, and you do user studies. But I think you will appreciate just this repetition. You probably know about it, but I had sort of an epiphany a couple of months ago. And then I'm going to talk a little bit about what Christian said in terms of scaling visualizations and how can we try to approach that problem. I'm not sure if I have the sort of the holy grail of doing it, but I think there are some interesting approaches there. And then I'm going to quickly show you what other things are going on out there. So if we look at technologies out there and sort of where do we want to be, I think the movie industry has shown us a long time ago where we should be, right? Interactive displays. Here he has pretty much all the data available that he wants, and it takes him a few seconds to sort of sift through the data and come up with the solution that he needs to take action. This display or this interaction capability actually exists, and I mean, you guys developed technology here at Microsoft sort of to start having gestures, interactive systems, and I think we're making a pretty interesting headway in terms of coming up with new sort of interaction models. So why do I think that security is one of the most exciting fields? Well, we have the opportunity here to make data understandable to everybody through visualization. And that's exciting because visualization can help us digest all the data that we have and communicate that to anyone out there so that they can understand it as well. We can help, in the security field, we can help protect pretty much everybody on the planet from the bad guys. And that can be a very interesting and I think fulfilling mission. Then we have an opportunity to play with some very interesting new technologies. If you look in the big data community out there that's going on right now. I think it's pretty exciting what's happening with all these new technologies from column-based database and key value stores. There's some really interesting stuff happening there that we have an opportunity to play with and hopefully also apply to solve our problems. And we have real-world problems, right? It's not like we're making up some kind of a fabricated problem out there, but we can actually solve real-world problems. And we have access to really cool technology to make graphs like the ones here in the background that in the end can look fun, they can motivate people to look into this and motivate them to also work with you. So anyone in here, I think you can make a difference with all of this. So my vision for sort of what I would like to see in security visualization is really sort of this application or framework that sort of tackles all of these different problems. And you don't necessarily have to be able to read the labels. They're more sort of cues to me to what to talk about. But it has to start sort of with the data. We, as you guys are you know, all of you have this big amount of data that we need to sort of deal with. And it's volume. You probably have terabytes or petabytes of data that you need to look at and make sense of. But it's also variety. So you have all kinds of different data sources that look completely different. They might have completely different types of information. And somehow we need to deal with that. And then it's not just the syntax of how these data sources look, and you have to sort of parse them and understand the structure of them, and maybe even deal with unstructured data, but it's also the semantics in the end that is associated with these records. And I will show you some examples where even that, just from a pure sort of textual basis, is really hard. So once we deal with sort of the big data issues, and there's a whole bunch of interesting problems in this space, we need to start with sort of an overview visualization to start seeing what's in the data corpus. And there are all kinds of interesting problems. What kind of visuals do you use to visualize a terabyte of data? There's a lot of data points you want to throw into there, and not everything scales to that. Then what dimensions or what fields do you pick out of your data? And that's not easy either, because usually you can't visualize 20 dimensions at the same time, so you have to sort of pick the most important ones, but which are those? Then from the visualization, from the overview, you sort of want to go into details of interesting views, but the problem is, well, what's interesting and what kind of views do I generate there? What dimensions do I use? What visuals do I use? You probably use different visuals here than you used in the overviews. For something like a network graph, you have links and nodes. They don't scale to hundreds of thousands of nodes, so you probably don't use them in the overview, but in the detail at some point that becomes very doable and you want to start using that there. From there, if you have one of these overview visualizations, you also want to be able to sort of interactively drill down and back up. And one of the issues there is that if you start drilling down, I have seen a lot of security analysts that spend hours sort of following a certain path to come to a solution, and then just to realize that they completely forgot sort of the scenario that they're playing in. They might come up with some solution here, but because they didn't put it into context anymore, the solution doesn't really matter. So how do we sort of enable that whole drill down and make this also very low latency so that I can sort of test my hypotheses very, very quickly? And then I have to these details, how about annotating these graphs and so that I can communicate them to other people? What about detecting patterns in there? How do we support that? How do we bring the human back in the loop of doing these things? And then finally, one of the things that we keep forgetting is that we might have this core corpus of data. We might look at time series, log files or something, but we forget that there's actually more context to this data. So if there's users in there, we might have a whole bunch of information about the users that we can leverage to sort of augment the data here. And there's a whole bunch of interesting things that we can do there to sort of augment our data with that context to give us more insight to do the analysis. So if you talk to people right there, they say, well, just do your data processing and then visualize it somehow. It's not that hard. Just throw it into whatever tools are out there. But that's not really true, right? And I think most of us know that, but a lot of people that demand these visualizations from us, they don't. The first question I would ask is, well, why do we even visualize the data? And one of the obvious reasons is because it's definitely the highest bandwidth that you can get from the computer to the human. The other thing is that we as humans have some really great capabilities, and one of them that's fairly obvious is we are good at finding patterns. We can look at a certain visualization and say, well, this looks sort of like it's periodic, but then there's this gap, and then it continues, or I can find very subtle patterns in there that would be very hard to encode in an algorithm that would find that, because we're okay with a little bit of fuzziness. Algorithms are generally not that okay with it. The other thing is that we're really good at remembering context. And that's important because if I raise an alert for a security analyst and say, this thing the traffic just dropped at 2 o'clock on Saturday, he might remember, oh yeah, well, it's an anomaly in terms of the data volumes, but I saw this email 2 days ago where someone talked about a maintenance window at 2 o'clock. So you have sort of this context that you don't even necessarily know that it's relevant to the data that you're looking at, but you can make that implication of things happening. Then we have intuition. We can look at a data set and we have all these other sort of knowledge at hand that we can draw conclusions between all these different fields of knowledge that we have. It was funny, I had dinner 2 nights ago with a couple people from the conference, and one of the guys gave a presentation on visualizing passwords. And he took a huge corpus of millions of passwords and he visualized the frequencies of them and so on. And he found that a lot of people are using dates as their passwords. And he had this one date, I think it was July 14th, 1789 or something. And the guy who gave the presentation, he just mentioned this number over dinner. He's like, yeah, I was wondering what that is, but we couldn't figure it out. We wanted to do some research. And then another guy that was at dinner is like, oh, wasn't that Bastille Day? Blah, 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 blah. And we were like, what? So we Googled it and it was right. So he had the intuition that that must be that day. So we're really good at doing that. If you gave a machine that problem to solve, it might take forever. This case might not be too difficult to find that date, but that's an interesting example of intuition, I think. And then we can also look at predictions. If we see a certain data set, for us it's fairly easy to say, well, if it goes like that, it might continue like this, and we can make predictions that are not necessarily obvious in the data. And one of the things that I will try to hammer home a little bit is that I think we need to enable the analysts that are looking at our visuals to come up with problems and not necessarily, or solutions, and not necessarily have it completely solved for the human. So help the analyst sort of come to the right conclusion, not necessarily coming up with the conclusion yourself, because generally the algorithms we can use to do that are going to be way too hard to come up with without having a high percentage of false positives. So, as I said before, and probably a few of you have noticed that security visualization is kind of hard. And if you look at the tools out there and maybe even research and stuff that people have done, I'm mostly underwhelmed with what's going on. And why is that? Well, I think one of the reasons is that cyber is this kind of weird concept. And for years, we have tried to come up with these analogies between cyber and the physical world. I have been talking to a bunch of government people, and they're like, oh, we would like to have a weather map of the internet. While I understand what they want to say, well, tomorrow it's going to be raining, which means, well, the financial sector is going to be attacked, or something like that. But we can't really translate these two worlds to each other. It just doesn't make that much sense. We have tried for years, and the analogies always fall down somewhere. So it's an interesting concept to grasp, and I have a couple examples in a minute how that manifests in tools and so on. But if we look at security visualization, what is that, and how is it sort of compiled? Well, we have the security piece, where we need to understand all kinds of things about networking and hacking and security and so on. Then you have the visualization piece, where there are things like perception and how do you generate different graphs and so on. And then you have other domains like statistics and data mining, or computer science, it's just the data processing. There are probably other pieces that play into here, but it shows that security visualization is really this kind of mashing together of multiple different other domains, which makes it hard because we have to be experts in all of it. If you look at security visualization, I think we have this mixture of these three domains at the very core right now, which is information visualization, where people come up with novel ways of visualizing data. Let's say years and years back, Ben Schneiderman came up with the tree maps, or Edward Tufte came up with the spark lines, or at some point Alfred Inselberg came up with the parallel coordinates. So that's sort of in the information visualization space. Then you have the visual analytics people that come up with new methods of looking at these data sets and interactions and so on. And then you have the security visualization, and it's sort of all mashed together, where I think what we need to try to do is really separate these things again. Because what I've seen happening, especially in academia, is that people publish papers in security visualization where they come up with a new method of a new heat map method or something like that, and they publish it in the security visualization. The problem is they got the security piece wrong. They didn't understand what the security problem really is that they want to try to solve. They did great work on sort of coming up with those new heat maps, but the paper was rejected, or it might have been accepted, but if someone looks for new methods in heat maps, they're not going to search in the security visualization field for that. So we need to sort of separate them. But if we do that, there are some interesting implications. I think from the information visualization field, we need a lot of help doing a bunch of things. We have different data. We're different. We have, if you look at a lot of the research that's being done, and a lot of the tools, they support measurements or numerical data. And there's a lot of research done on that. How do you visualize that, and how do you run data mining algorithms on that stuff? The problem is, in our world, we have a lot of log files. And that's mostly categorical data or nominal data. So if you look at the log file, there's users in there. I can't sort them. I can't say Christian is taller than Anthony or something, right? It's just, you can't really sort these people that way. It doesn't make any sense. You have URLs in there that are even worse. You have these long, long strings, and how do you sort those? How do you define distances for them? Then IP addresses, we have tried many, many ways of visualizing IP addresses, and I see anything from maps to putting things on a globe and spinning the globe and all kinds of stuff. And often that's just not very useful for analytical purposes. It might be a great marketing tool, but to analyze things and get insights, it's not necessarily that good. And then we have a lot of hierarchical data, where you have, for example, you have user roles, you have users have privileges, so there's all kinds of hierarchies in there. IP addresses are in a certain way hierarchical as well. If you have the networks and the machines, and they might have different roles even. And for all of this, there are really not that many visualization techniques out there that we can apply. Another field that we need help with from the information visualization field is provenance, and that's something that I'm just personally very interested in, which basically looks at what are the steps that someone takes in analyzing certain data sets? How do they progress through a tool? What are they doing? And there are all kinds of very interesting things we can do. You can either start backtracking in your visualization process, and someone else can look at that process and say, hang on a second, I want to jump in here, and I want to try something else from there. There are all kinds of very interesting things that we can do here. Now, if we get help, or what I see done wrong a lot, is that we make the wrong assumptions on our data. One of the assumptions is that port numbers are continuous, that there are ranges from 0 to 65,000, and we can sort them that way. Well, that doesn't really necessarily work, because port 80 and port 443 are very close to each other. They're both transporting web traffic on them, so they should be very close to each other. But then 80 and 82 are probably as far away from each other as 1600 and 32,000, right? So that has very interesting implications on the visualizations, and even worse, if you start doing data mining and you're defining distance functions and you're using that as a numerical dimension, you might run into all kinds of very interesting artifacts that will come out in your data that you really don't want. So the distance functions are hard. Again, it's on ports, it's hard, on URLs. How do you do that? You can define, people have tried all kinds of things where, like, edit distances, or you just compare, and if they're the same, you have a 1, and if it's not the same, it's 0, but that doesn't really make sense, because maybe you want to look at the path structure, but there's all kinds of interesting things to be done there still. I keep seeing research coming out where people are creating these completely new visualizations that are super hard to interpret, like crazy glyphs with like concentric circles and like 4 of them, and they're different thicknesses, and that means something, and then you have rays coming out, and there's a whole bunch of stuff. I think we should leave that to the information visualization people, and they should do their perception studies on it, and then we should leverage all that stuff. And then the IP addresses, and I will rant on that in a couple of seconds here. So here's an example that leverages existing visualizations. It didn't come up with a new way of representing the information. He just used a tree map. This is an example from Chris Horsley in Australia, where so he has this tree map, and he basically has, I think, about 25 different sensors out in the internet. Every sensor has a color in here. And then inside he shows port activity. And the interesting thing is he made really interesting use of the tree maps and the coloring here. What he did is the brightness of the color shows whether you had a lot of traffic in the last 5 minutes. So if it's bright, it means you had a lot of traffic in the last 5 minutes. And if it's darker, you didn't have that much. So what he can do with this is he can say, well, I see what happened in the last 5 minutes. You see all the bright spots in here. But he can also say, well, if I see bright spots for the same port number across all of the sensors, I have some global phenomena going on where there might be some malware spreading on this one port, and suddenly it's flooding the entire grid of his sensors. So I thought it was a very interesting way of an existing visualization, but a very creative way of leveraging that. Another reason why security visualization is hard is because of terminology. If you're talking to a security person and you mention the word graph, it's something like this, right? It's a chart, it's a bar chart or something, it's a graph. If you talk to them about a network, well, a network is machines connected to each other and there's wires and whatnot. But if you talk to visualization people, a graph or a network generally is a node-link graph, right? So this is a kind of an obvious example, but I think there are also issues going on here when we talk to these between these different domains. Then the topic of IP addresses, and I mentioned that before. These are all examples of sort of visualizing IP addresses in different ways. They're sort of more on the logical level here. You put them on maps, you put them in the globe, and you have 3D bars coming out. The one at the top right was a presentation at VisSec just on Monday. Uses this sphere in the middle, which represents the internet, and then you have all kinds of circles or rings around that. It's all animated. I encourage you to watch the video. It's great marketing. But the problem is, so they're monitoring different customers here. Every ring is a customer, and they're monitoring traffic. And if the traffic goes from the customer to the internet, there's a line here. But the problem is, analytically, there's really barely any value in here. The value they're getting is that you see maybe volumes if you see a lot of these lines going to the internet, but you can visualize that much more effective if you use like a little bar chart or something that maybe even animates or so. But so the point is that it's not always the right way to put data on a map. For example, here I might have 10 different offices or whatever locations in the world, and I show where they're lighting up. But in the end, it doesn't really matter here that these two offices are very close to each other. The maps are great if physical proximity actually matters to the data that you have. Here, I could probably, again, show a bar chart of every location and even show the amount of whatever is happening here, and you would have a quantitative and not just sort of a qualitative view like here. So I'm kind of frustrated that people keep trying to visualize things in all kinds of different ways, and we haven't come up with that one visualization that is really gives us insights about our IP addresses. Another reason why it's hard, and this is probably one of the core reasons, is that it's just hard to understand these log records or the data that we have. So if you look at this single line here, can anyone tell me what that means? This I found in the Linux kernel. Sorry, I didn't have a Windows kernel example. But if you read this, there's barely any information in here. There seems to be a state change. There's this number here that changes, and funny enough, it's the same number. So I have no idea. I haven't found anyone or anything that could explain this log record. I think at once I even tried to grep through the source code of Linux to find where the hell this is generated, but there's really not that much you can grep for. So I have no idea what this means. Now, multiply the problem if you have 100,000 records, maybe even if you understand some of them, but that problem of understanding what that means in concert is going to be hard. Then one problem that we keep ignoring is if we don't know how the data is generated that we get, it's really hard to say whether the absence of a log record actually means that it didn't happen or it just didn't happen. If I configure this thing to not record traffic from Christian to me, and there's no traffic there, I don't know if he never sent anything to me or just never recorded anything. And that's important to know if you're doing an analysis. And then if you try to figure out, you don't have to read this whole record here, but if you're trying to figure out is this normal or not, it's kind of hard to say. Normal in regard to what, in what environment, like who is doing this, and so on. So these problems just sort of multiply if you have larger amounts, and visualization is not going to help you. Right? Then another issue is that I think often we're collecting the wrong data. Most people are sort of looking at traffic flows and intrusion detection data. That's A, true in academia, and B, in large corporations. I see most, even Fortune 500 companies, they're maybe collecting traffic flows, even more firewall data. They generally collecting intrusion detection data, maybe a couple of other data sources, but when I go to them and I'm like, so you had an incident, what did you do? How did you look at all that data? They're like, well, we threw all that away, we installed a probe, we started capturing packets, and we looked at the packets themselves to figure out things like HTTP header sequences to see in the web request what were the headers that are in there, A, which ones are present, and B, what's the sequence of them, in order to find things like botnets that just have different signatures in there. But they didn't collect that data up front, so it's kind of useless to collect this data. They also look at a lot of DNS data, again for botnets. It's very interesting to see what domains are being resolved and so on. And then if you look at other issues like fraud or data exfiltration, you generally have to start looking on the application layer. And that brings a whole slew of different problems with it, where you have to be able to understand them and parse them. There's all kinds of different formats. It's a problem in itself, and people spend too little time on those problems right now. So I think we understand why it might be hard to visualize data, but it's really not necessarily that hard. I've been thinking a lot about how do I visualize a large amount of data lately, and I was trying to figure out, well, how do I build a backend that really scales to high volumes, very diverse data, and has low latency when I interact with it? And I talked to a bunch of database people, and they basically told me that I'm crazy because what they usually want to know is like, how does your data look? And then they give you a schema, and then they're like, okay, what are the queries that you're doing? And I said, well, I don't know. It's anything. The user is going to do whatever they want. They want to look at it in all kinds of ways. And they're like, you're crazy. We don't even know what indexes to run on this stuff, so we can make that fast. And that's sort of a catch-22 problem in the relational database world. But what I realized then is I was trying to design the system to look at a terabyte of data, say, over 6 months of worth of data that I had. Well, that's something that my customer told me that they want to do that. But just to realize later that, you know what, you're going to do this exactly once. You're going to do that when I give you the tool first, you're going to look over 6 months, and then you do your analysis and whatever. But then going forward, you will probably look over the last day, maybe over the last week, maybe over a month. But that's definitely the maximum. You will never go back to 6 months. And I just built this incredibly expensive system to deal with 6 months of data. So what I realized is that we need to really focus back sort of on a process where you kind of understand, or you start sort of with understanding the domain, you try to innovate and come up with your problem that you want to solve, and then you need to understand your users. What are the people, the types of people that you're trying to interact with, and what are their scenarios? What did they try to do? In my case, it's the security analyst that probably looks at this every week to see what happened over that week of data. And then you define sort of that use case to solve the problem, and you probably want to start designing sort of user interactions here and start verifying that with the users. So keep talking to them to come up with that solution. And then you probably go and design your backend. So instead of already defining the backend here, when you say, oh, I understand the user, he wants 6 months of data. That backend here is going to look completely different. And then you can start doing sort of your design work with more of UI. Some of the UX is already done. And then you start developing. And here, I think the whole like kind of lean startup development methodology or also Scrum sort of where you develop very quickly and you get something in front of the user so they can start playing with it and you can make changes from there. So again, I feel like this has been fairly instrumental in my thinking in also analyzing large amounts of data. There are batch processes where I need to be able to every now and then look at trends over large amounts of data, but I can usually batch that and say, just go run this, and I don't care if it takes a day, but there are other use cases where I need the data right away, where I need to look at a day of data and have very high, low latency interactions, basically. So I said we need to understand the user, and that's generally the security analyst or someone that actually interacts with this data. Well, the security analyst is kind of an interesting persona, kind of like the security visualization domain itself. This guy is sort of a mix of an expert in all kinds of areas. They need to understand security, obviously, so how are threats looking out there, how do they manifest in a network, how do they manifest in applications or operating systems. They need to understand operating systems themselves to sort of understand what these, if you look at sort of traces or something like that, how does that manifest? How does an operating system serve up different things? They need to understand networking because generally the attacks will come over the network, so they need to understand routing and all kinds of things like that. And finally, they even need to understand the business, because if they don't understand what we're trying to do with the business, we don't necessarily know what's normal and what's not. If I don't understand that I have a certain financial process going on and I have all these applications supporting that, I might say, well, it's not normal that I have all this traffic here, but if I understand these things, then I can make better decisions there. Now, a very interesting issue comes if you start doing user studies and you start talking to these analysts. And this is a very provocative view, and I'm not saying every security analyst is exactly this way, but the first problem is that there's no real certification process. If I become a surgeon, there's a certain process that I go through to do that surgery. Well, there's no real process that we have for doing security analysis to sort of look through a big corpus of data and come up with the attacks. Everybody kind of does whatever they feel like and whatever they learned or their background is. You have a humongous range of knowledge of these security analysts. There are some that just come out of school, have never seen much network traffic, and they're there and doing security analyst work. And then you have others that have much more experience. You have a wide range of tools. Some people use whatever tools for grep and awk and set and whatnot, or Perl to analyze some of the data. Others have huge systems like an ArcSight or a Q1 or a Nitro or something like that lets you do the interaction with the data. And people just do their job completely different and not necessarily the best way possible. So if you start doing user studies, you will learn sort of a biased view of this one analyst, and you start building that tool for them. Even if you're going into a larger population of analysts and start getting feedback from them, you will realize they often have a hard time even telling you exactly how they do a certain piece of work. They have intuition on how to do it, and they will be able to dig in, but this is a very big problem that we're facing, that we don't really necessarily know how security analysts work, and we're building tools for them based on this biased view. All right, so let's shift gears a little bit. And I was trying to ask this question, how do we visualize a terabyte of data? Well, if you throw them into some visualization, you often get a hairball like this, right? It's like, what now? I'm really not sure what to do. Well, Ben Schneiderman came up with this model, and this is fairly old and it's probably fairly obvious, but this is sort of the way you have a chance of addressing that problem. You need to start with an overview, because if I give you a terabyte of data, you're not just going to dive into the first 10 megabytes and say, oh, this is here, what's going on in here. You sort of need to have the big picture. And there are certain visualizations that are capable of visualizing a large amount of data. Granted, there's a lot of aggregation going on in here, but a time series visualization like this could be giving you some insights. Like you have these two spikes here, and then you have a gap. That might indicate something going on. If you try to throw all this data into a network graph like this, good luck. It's probably going to be the hairball. You have other visualizations here, like heat maps. I like a lot because they're sort of space filling. There's a lot of detail you can throw in there. So from here, you might say, well, I'm interested in this spike, or I might want to look at this time period here where there's barely any traffic going on. And then you use some other visualization to sort of look at that detail to try to understand that. And even in here, I might find, oh, there's this cluster up here, I'm very interested in that. This seems to be interesting behavior, but often the visualization doesn't contain all the details that I want to know about. So I generally have to go back to the details of actual individual records to start looking at them to answer what's really going on. So we need to have all these different things present in a capability that we have to look at the data. Now this might be a minute detail here, but if I have an overview visualization, it doesn't always mean that I jump from here into some zoomed in version and I use different visualizations already there. Often I might say, well, I have all this data, but I need to keep iterating on this one and start throwing stuff away I'm not interested in. So I might say, well, in here, I really don't care about anything else, it's just like this period over here, and I come up with another overview visualization and kind of iterate on that. I might throw away certain data sources that I'm not interested in, or maybe even certain dimensions of the data or fields that I'm not interested in. So with all this, or one of the trends why we're even interested in sort of visualizing larger amounts of data is because we start collecting more and more data. And the good thing is the whole big data movement sort of starts supporting us in doing all this kind of stuff. And I think we haven't seen the crazy visualizations yet for terabytes of data because we didn't even have the capabilities to process this stuff 2 or 3 years ago. I mean, you had to go to a high-performance computing center or like a crazy parallel computing infrastructure to do your jobs. Today, you can boot up 1,000 machines in 5 minutes and pay very little money to do a computation on them. So we get all these capabilities in our hands. We have almost limited storage if you use some kind of cloud system. I don't think they're going to run out of, Amazon is not going to run out of storage if I throw all of my data up there. And we have all these capabilities on demand now where I think there's coming more and more. Now I have MapReduce on demand. I don't need to install a Hadoop cluster myself. I basically throw it into Amazon and have them, or put a job out there and it runs. Or I have a database. I don't need to set up my own MySQL instances anymore, or Oracle even. I can just use one of those services to do that. So that's very interesting and allows us to do all kinds of stuff without that much knowledge anymore of the back end. And then you have all these new sort of storage paradigms that are trying to help us process more data. The really hard part here is, and we talked about this in the car a little bit this morning, is trying to figure out, well, which one is the right one for my problem? And are some of them maybe not even really that important to what we're doing? And then if you start saying, well, I need a key value store, about 4 of them out there, or 5, that make sense to be used, but depending on who you talk to, you will get different answers on what you should be using. So you have to really start digging in and understanding all these technologies to figure out which one really to use. This is a quote I find, unfortunately I don't know the source anymore, but memory has become the new hard disk, and hard disks are the tapes of yesterday or years ago. And that's an interesting thing if you think about that in terms of how do you architect a system. You can, if you look today, you can build a system that says, well, I have, I don't know, 32 gigabytes of RAM available in my server. And that's fairly common at this point. And you build your system with sort of a caching layer that does some stuff in memory. Well, if you extrapolate that a few years out, you probably have a terabyte of memory in that server that's costing you the same as the 32 gigs today. So depending on what you're doing, you might be able to actually build an infrastructure that just throws everything into memory. You can buy 10 machines, each 128 gigs of RAM, and you have a terabyte of RAM basically. And we have the capabilities to address all of that stuff and distribute our tools that way. So sometimes you have to optimize certain things, sometimes you throw hardware at it. And the cost benefit is actually, gets very close. So keep that in mind. So now, I've been thinking about this sort of interplay between visualization and data mining quite a bit lately, where I was very bullish a few years ago to say, well, we just need to visualize the data and that's it, and you give it in front of the user and let them interact with this visualization. But I don't think that's the solution. Well, quickly, let's look at briefly what is data mining. Data mining has a bunch of different sort of sub areas, I guess. One of them is anomaly detection, where you try to run an algorithm. There's a bunch of different ways to do this on the data, and it sort of flags anomalous behavior. You have association rule learning, and one of the examples here is sort of that market basket example, where if I go and I buy, I'm not going to repeat the joke that I ran into at BizSec. I said I'm going to buy Coke, like Coca-Cola. And they can predict that, well, if you buy Coca-Cola, you might also buy cornflakes. So they come up with this basket that are very likely to be bought. So that's one of the examples in here. You have clustering, where you take a certain data set, you say I want 10 clusters, and it basically tries to separate your data into 10 sort of different areas of that sort of belong together. So you might cluster people based on certain attributes, and it comes up with these clusters. Classification is where you already have sort of the groups that you want to throw things into, and it takes the data and it sort of distributes them in these classes that you have. Then you have regression, where you sort of model your data. You come up with certain, you can also do predictions on here to say how likely is it that someone converts in my browsing behavior to a customer, things like that. So it seems like if we had all these algorithms, especially the anomaly detection and finding outliers, well, we're kind of done. That's what we want to see, the anomalous stuff. Or we want to have a summary of the data. Well, why don't we just run data mining on this and be done? Well, why do we need visualization? This is you might have seen this before, NCOM's quartet. These are basically 4 data series here. If you look at them, these X and Y coordinates, if you do all kinds of statistics on them, you will see that the mean, the variance, the average, the regression line, they're all exactly the same. So from a sort of computational perspective, that doesn't give us that much. But if we visualize these 4 different data series, they're completely different. And by just looking at them, we're like, oh wow, okay, we get what this data set looks like. So visualization was able to give us very quick results. Well, you could try to run some data mining algorithms on this stuff and do clustering or something, and probably here it would do pretty well and find that cluster. But on the others, that wouldn't perform that well, and how else would you analyze this data? So visualization is I guess, still needed. Here's an example of more of a security example where I took the trust relationships between certificate authorities. And so they signed like SSL certificates, right? So what I did here is I only took a small piece of the whole worldwide trust relationships. But if you look at this, there's some things that stick out very quickly, where you see that this guy here has a lot of children that they signed, and these children trust that one authority. This is the DN cert, the German cert. And initially I was just like, boy, that's kind of weird that this guy is still trusted. But then 3 weeks ago when I was teaching a class in Iceland, actually a couple of guys from DN cert were in the class, and they're like, oh, do you know why that is? I said, no, tell me. They said, well, see, what happened is the DN cert used to sign all the different certificates for all the universities and everybody in Germany. But then what they did is they introduced this new layer in between, where now every university is their own certificate authority, and every cert is an authority. So now you have the DN cert, they sign all the other ones, and then they sign the individual's SSL certs. So it's a very benign explanation why this guy is so big here. It probably also shows that this visualization is a little flawed, because in the end, this doesn't mean that this is a critical point, although it's really sticking out. It just means that they distributed their trust, basically. So you might want to do something else and use the size as the number of certificates they signed or something like that. But the interesting parts might actually be here, where you see that, well, why is the answer connected to this node here that's sort of connecting 2 other clusters? And running a specific algorithm on this, you might have found this big cluster of the answer, but you might have never seen those 2 relationships that are going out from there. So I think this kind of motivates why visualization is still an interesting approach. Now the question is, how do we combine data mining and visualization? I think we realize that both of them are pretty meaningful. What I think is we should leverage data mining to augment the visualizations, and there are 3 sort of areas, there's maybe 4, that make a lot of sense to me. One is in data overview. If I have a large amount of data that I have not seen before, I need to get a feeling for that data first. And things like summarization or some statistics, usually what I do is I go through every dimension in my data. I want to know whether it's categorical or numerical. If it's numerical, I want to know some statistical properties like variances and means and so on, that I have an idea of what the data is in there. If I have categorical data, I want to know the cardinality, how many different things are in there, and maybe get a sample of what they are. And there are things like scatter plot matrices, or there's a bunch of other things like parallel coordinates you could use here to sort of get that overview and help visualize some of that data. But if you have large populations, like for these network graphs, some of the things you probably want to look into is clustering. To basically break up, either break up the big visualization into individual clusters that you can then analyze on their own, or you can try to simplify the large network graph and basically only show the individual cluster nodes and see how the clusters are connected with each other. And there's all kinds of things you can do here. And then if you have high dimensionality, so you have a lot of different fields in your data, you have usernames, URLs, bytes, timestamps, and so on, you probably want to try some dimensionality reduction. Which of the dimensions actually matter? Which is the most important dimension that qualifies your data most? There's all kinds of different algorithms here, or you can do projections into other dimensionalities to sort of pack all that information in less dimensions so that you can start visualizing that. But I think I'm a big believer that we should leverage this, as I mentioned earlier, to augment the visualizations. I have seen too much research where people ran anomaly detection sensors and tried to come up with what's going on in this network, and they flagged these different things, but the false positive rates are just way too high. Even if you get into below 1% of false positive, well, if you have 10 million records, 1% or even 0.1% is still a lot to go through. So if we can leverage data mining to sort of improve the visualizations and bring the human back in the loop of iterating on that stuff, I think we have a chance of actually solving these things a little bit. So there's still a bunch of issues with data mining, obviously. One that mentioned is distance functions. They're a huge, huge problem. There's a lot of parameters that, if you read research, people just kind of swipe under the rug. They're like, oh, we just assume 0.5 for this, and they keep moving on. It's like, well, why did you do that? And if you didn't do that, what's the impact on the whole process you went through? Mostly the data mining stuff works in continuous data. Again, you have to sort of map your categorical values onto numbers to make it even work. And there's really not that much out there that deals with categorical values. Yeah. So here's a quick example. I took a bunch of user activity, threw them in a heat map over time. So these are all users here. You have time, and the activity, the more blue or darker blue it is, the more activity I have. And this is just randomly sorted of just however it came in. And you see different sort of trends in here. There's a few users that are very active, others become active for a certain period of time. But in the end, this is way too much data for me to kind of make sense. What's interesting in here? Well, the first thing I did is I clustered it, and this one here came out. And it's kind of interesting because there seem to be users that behave very similar. And then I have a whole band here that I might investigate and say, well, what's all these guys that have sort of repetitive behavior, or why is there this big cluster of activity here? So I can start investigating these things. But what it also shows is that the distance function that was used, this is just pure R, Euclidean distance on the difference between the rows. The distance function made the clustering algorithm break these pieces up in a top and a bottom. Whereas if I did this manually, I would probably combine these two into one cluster or put them closer to each other. So coming up with the right distance function is still a challenge here. But at least it separated my data in certain ways, and I could probably throw away or investigate all of this stuff that's very white here by itself. So it kind of helps me focus on the pieces I want to look at. All right, so going forward, every presentation has to have a future outlook. So there's a couple of very interesting things happening. One is visualize this. If you have been to challenge.org, there's a whole bunch of government agencies that actually encourage to do public challenges. And the NSA is doing a challenge. It's hopefully going to happen. I was just told if you actually go to their website, it says in 58 days it's going to open up, but I was told that's not clear yet. There's a lot of red tape from lawyers because it's the NSA and they can't say certain things. So hopefully this is going to happen. What's going to happen here, the challenge is that it's a very low-tech challenge. You're not giving a data set. What you're given is a scenario where you have to build a display for a network manager where you have to visualize a 1 million node network and help the network manager understand very quickly what is happening in that network. And you're given a bunch of scenarios like a router keeps rebooting, there's a bunch of malware infections on these machines, there's a number of servers and a number of desktops, and basically the call is for anybody, designers and people that don't have too much domain knowledge, to come in and help be very creative on how would you visualize such a huge network for this network operator. Then the VAST community has these challenges. One just ended, and it was presented here on Sunday, where you're actually giving a data set, and a pretty large data set, and you're meant to build tools and come up with methods of figuring out what's going on in the data. There's going to be a new challenge next year. It's probably going to be bigger and better. There's also a mini challenge happening before the big one next year, where they are trying to leverage visual analytics for movie predictions. And I found that very interesting because I haven't really thought of visual analytics as a predictive tool that much. And I talked to the organizers and I'm like, do you have any idea how people are going to do that? They're like, no. But that's our challenge. We want to see what people come up with if you leverage visualization to predict things. So it's actually almost a live challenge where for new movies, you have to predict how they're going to do at the box office. So that's going to be interesting. Yeah. So to go forward, this is sort of the vision slide I had in the beginning. I hope that we're going to be able to come up with this framework where we are able to deal with a lot of data, and a lot of different data with very low latency queries. And there's a bunch of work being done here at different organizations, the big ones. I'm sure you guys are working on these problems as well. What I would hope is for the security visualization community that we almost get like this virtual machine that I can download. There's a certain data set on it with a data store already installed, like some, I don't know, SQL database or something, and then maybe even pre-computed aggregates so that you can very quickly interact with the data, and that people don't have to rebuild sort of that data pipeline every time they're doing some research on this stuff. Because I see too many people that do, like the VAST challenge, for example, people spend 60–70% of their time building a data store that supports low latency queries, and then they have time to very quickly put a visualization together and it's like, oh, here's the result. So I wish that we have some sort of a framework that people can plug in and start really focusing on the visualization pieces. So I think I'm not going to go through all these challenges I think that we still have in these areas. There's definitely a volume challenge in visualizing the overviews. There are very interesting problems of how do we, for example, leverage provenance and security so that we can predict how people are analyzing certain data sets. And how do we leverage, what's the exact interaction between machine learning and visualization? So I think we still have a lot to be done. It's a very young field still. And with that, I'm going to leave you sort of with what we started with. The meaning is right in the data. You just have to figure out how the hell to look at that data to bring it out of there. All right.